Hello, friends. Welcome back to Break Program, and hope you all are doing good. So here in our current video, we are going to start with the next step of major phase. In a previous video, we have just gone through performance standard, where we somehow try and convert a problem into measurable characteristics. We documented the problem into measurable characteristics. So right now, we're just going to go through a next step of measure phase. Remember, measure phase is all about measuring how deep is the problem. And to measure how deep is the problem, we got to measure the critical causes as well, right? You could remember y is equal to fx. So for every problem, there are certain causes behind it, and we need to somehow curb those causes. Six Sigma help to find out significant causes and fix those causes. But to find out significant causes, we got to first of all list down the probable causes, and that's what the next step we do have. So let's quickly go through next step. Next step, please. Right. Yes, we talked about this. So very first step was defining how we are going to measure the problem. We use performance standard. Now the next step, a second step in measure phase is listing out probable causes leading to problem, and we're going to use the tool called fishbone diagram. Let's go quickly to fishbone diagram. Try and understand fishbone diagram, how we are going to use fishbone diagram to list down the probable causes. So step 2, root cause analysis. Fishbone diagram based root cause analysis is all about finding out root causes that do have impact on y. That's for project y, and that's the metric we're just working upon. So let's go to the next step. Well, fishbone diagram is also called Ishikawa diagram and is also called a cause and effect diagram. So this tool, fishbone diagram, is invented by a scientist named Kaoru Ishikawa in 1960s. He pioneered quality management process in Kawasaki shipyards. So we also call this diagram Ishikawa diagram. This diagram has a structure like fishbone, in which the main central bone is a problem and branches of bones are possible causes. In simple words, RCA, that is root cause analysis, means various reasons due to which this problem occurs. We somehow try to collate those causes. That's what RCA is all about. Let's go to the next step. Right, so Ishikawa diagram, which is also called a fishbone diagram, cause and effect diagram, it also further segregated this list of causes into various groups or categories. So, the very first category is man-related causes. Second category is machine-related causes. Third is method or policy-related causes. Fourth is material-related causes. Fifth is measurement-related causes. And sixth is environment-related causes. Most of the time, this environment-related causes are not under our control. These are external environment-related causes. So these fishbone diagrams help us to categorize causes that lead to the problem. Hence, fishbone diagram is also called cause and effect diagram. So let's understand man-related causes, means a human-related causes. Human error is one of the aspects, for that matter, or any training or wish factor, where the individuals is really willing to work, he's or her a skilled factor will come into the picture. Are those the causes behind the problem? So we segregated all those human or individual or personal or people-related causes under the category of man-related causes. Second is machine-related causes. The word itself suggests any cause, any issue associated with the machine. If that is the reason why the current problem is occurring, so those are the machine-related causes. Methods are the procedures which we do follow. We do have certain process, step 1, step 2, step in to form or formulate certain product or develop certain product. So are there any gaps into this particular method, or for that matter, are there any issues or challenges associated uh, within our methodology or within our procedures which ultimately lead to the problem? You know? So all those method, procedures, and methodology, the way we work, the way we produce something, if we do have any issue associated with methodology or with method, all these will come under the compartment or category of method. Next is material related causes, raw material related causes. Suppliers not, fulfilling the requirement or not giving right quality, raw material or any other stuffs regarding materials, which we do use as an input to process and further convert into output. So that's a material related causes. Fifth is measurement related causes. Measurement is what, once we formulate a particular product, or uh, once we develop particular service or product, we need to measure whether things are properly deploying or not. So we always used to have a quality assurance team, quality control team. So are there any issues associated with the proper with the measurement? You know, so if there are any issues associated or probable issues or causes associated with the measurement that might lead to given problem, those causes will come under the compartment or category or division of measurement related causes. And of course, we spoke about the sixth one, environment related. Environment in the sense, external environment in this case. Environment is external environment, mother nature, which are like somehow not under our control. So those factors. So these are the six different categories of Ishikawa or fishbone diagram. Let's go to the next slide. Right, this is how it looks. You have, problem Y over here. Right? Example, high processing time non-compliant. That's what our case. So this is a Y. Man-related causes will come over here. Probable X, X means cause. So you'll put down or you'll jot down the causes over here. Man-related causes. Material-related causes will come here. Measurement-related causes will come here. Mother nature or external causes will come here. Method related causes will come over here, and machine related causes will come over here. So imagine you have a list of different causes. So instead of just coming up with the list of different causes, if you could categorize the thing, if you could sort out the thing, that the easiest way to sort out the things is through fishbone diagramming. This is what we are sorting out. We are sorting the causes into different compartments so that we can very easily visualize those causes. And that is the power of Ishikawa diagram. So we do have a problem here, different compartments or categories over here, and then we'll segregate different causes as per the compartment or categories and jot it down over here. So try to imagine you're sitting with the operations team. There is a whiteboard. On a whiteboard, you somehow draw this fishbone diagram, and you start discussing what are different probable causes, and team discuss about the causes, and they comes up with the causes. Then imagine they comes up with the first cause. Then the next question which you need to ask is, okay, under which category it looks to get fitted. So, okay, it could be man-related cause or material-related cause. So on that whiteboard, under that fishbone diagram, you're going to jot down that cause under selected category. And likewise, every single cause, when you will discuss it with team, and then you will just categorize them or compartmentalize them so that it will be easy to visualize and it will be easy to find them out and their importance are. So that's about the Ishikawa diagram. Right. So case study. Our case study is to reduce processing time non-compliance. So as I mentioned, brainstorming session is conducted among shift supervisors, experienced and fresh operators. So imagine there are like 5 or 6 members are sitting over there in a conference room, and you are there in whiteboard, and then you started discussing what are the probable causes, that impacted the processing time, right? So this is how you started the discussion. The session is led by assistant manager. Fishbone diagram is developed. So we already discussed that you drew that fishbone diagram on a whiteboard and you started asking them the question, what are the probable causes, and then you categorize them into different sections like man related cause, or machine related, or method related, or material related, or measurement related, or external factor, or mother nature. We call it mother nature related. So that's an external factor. The different probable causes are classified under the category man, machine, method, material, it's material, measurement, and mother nature. On next slide, we can see the fishbone diagram and categorization of the probable causes. So let's go to the next slide. This is the why, and for our current case of PT, that is processing time non-compliance, these are the probable causes we do have. So let me read a few of the causes for you. So high processing time non-compliance is the problem. Man-related are human errors, operator partial skill sets, personal breaks. So these are the man-related causes. So those will go into the compartment of man-related causes. Poor estimation of material quantity, wrong material, raw material ordered, or poor quality of raw material in stock, that will come under material. So likewise, you'll segregate different causes into different categories. By the way, these are the not the significant causes yet. These are the probable causes. They may or may not be the causes. But right now, in a brainstorming session, we're trying to come up with as many possible probable causes as you can with the help of operations team. So that is what we do it into our current project of reduction into PT non-compliance. Let's go to the next slide. Right. So there are different types of categories for different industries. So when Six Sigma started, as we all know, it was more or less for manufacturing industry, and that is why this man, machine, material, measurement, method, all these are manufacturing related categories. But if you're talking about IT industry, for that matter, those categories will differ, right? So not necessarily we will put everything under the same categories for every single industry. For IT industry, there might be different different categories. So let's understand the probable categories of the causes for IT industry. So when we normally do Six Sigma project deployment for IT industry, these are the 6 different categories which we use. Yes, there might be some other categories, but more or less we try to put the things into, or most of the causes will somehow get categorized into these 6 categories. First is people related, just like man related. Second is environment related causes. These are not the external environment, the environment which we use for software development. So are there any issues associated with that environment which we use? Third is IT development or training related causes. So in manufacturing, we had method related causes, if you could remember, methodology and procedures which we follow to develop given product or process given product. Here it is IT development or training related causes. So training are equally important. So that's why we are just somehow combining these 2 things under one category, IT development or training related causes. So anything associated with the process or procedure of development or training of software professionals will come under the category of IT development or training related causes. So first people related, second environment related, software environment related, not an external environment related. Third is IT development or training related causes. Fourth is coding related causes. Are there any causes associated with the coding? Right, so that's the 4th one. 5th is QA. QA is like your quality assurance team. So are there any issues or challenges or causes which further lead to impact the metric, software metric, right? Software development metric. So those things will come under QA related causes. And finally, client related causes. So are there any issues? Are there any delays from the client end, or are there any so-called called causes from the client which really affect your software development, or software development metric for that. So all those will come under client-related causes. So to sum up, for IT industry, we may not necessarily will use the same categories which we use for fishbone diagram in the manufacturing industry. For IT industry, these are the 6 probable categories under which we can segregate the causes: people related, environment related, software environment related, IT development or training related causes, coding related causes, QA related causes, and client related causes. Let's go to the next slide to see how it will look for IT industry. So project Y of IT industry. Let's take an example. So what would be the IT metric? Your metric defect density. Yes, defect density is one of the metric which they use in software development. So this is how you can just categorize people related. The defect density is my metric. Of course, that's one of the very important metrics. So if my defect density is high, now what is defect density? Defects associated in developing the product. In a very simple nutshell language, defect associated in software development. So what are the causes? Here we are going to categorize those causes into the 6 different categories. People related, that is software engineers related for that matter. Coding related, quality assurance team related. This people related is more or less developer related causes. And these are QA related, quality assurance related. Then client related, IT training and development related, and software environment related. So this is how it would look for IT software development or IT operations team. So that's for IT or ITO or the IT operations or ITES industry, IT enabled services industry, which is more or less BPO, KPO, contact centers, and all those. So we have seen the example for manufacturing, and we have seen the example of fishbone diagram for manufacturing industry, and also for IT operations, IT enabled services related fishbone diagram. Let's go to next slide. Now, sometimes what happens is it is difficult to categorize causes into given categories or groups shown on the previous slides, both for manufacturing and IT industry, or for that matter, for any industry. It is really very difficult to categorize those causes into a given category of man related. It's supposed to be in a man related, or it's supposed to be into material related, or if it is the IT industry, it's supposed to be in a coding related, QA related, client related. It has to be the flexible one. You are not supposed to strictly communicate that these are the only categories one supposed to use in a fishbone diagram. That is not is expected out of fishbone diagram. Why we are doing these categories is to somehow help us categorize and visualize the causes or segregate the causes, so that we can very easily see or look towards the causes. So that's the sorting, that's the benefit of the sorting. And that is what fishbone diagram is suggesting to us. It's a visual sorting technique, to be very honest. So visually sorting technique. So you're sorting the list of causes. So we are not supposed to just bother, or for that matter, we are not supposed to make it compulsory to use the same categories. If for a given industry or for a given project, if you couldn't categorize them in a given category, that's absolutely okay. So in that case, instead of using standard categories, you can also write actual causes in the head here and sub causes of each head on branches. These are the branches. So cause 1, cause 2, up till cause n. So if this is your project Y, this is the heads of all causes. So cause A, you put it over here, and anything related to cause A, that is sub cause, you just mention over here. Cause B, sub causes. So you're not putting man, machine, material over here. Simple, whatever 6, 7, 8 causes, not necessarily even 6 causes. Here you have 6 different heads. You can have 8 heads, you can have 10 heads, and under which you can go with the sub causes. So that's a segregation by sorting the causes, so that we can visually showcase the causes. So this is another way to somehow segregate the causes. So we have seen how manufacturing industry can segregate. We have also seen how IT operations, ITES industry can segregate. And this is another way, which is common and general way across all industry, including manufacturing and that of IT as well. So there is no compulsion to use the same category. That's what I'd like to sum up it. So that's all about fishbone diagramming. So this is a quiz time now. Let's go to the questions. Fishbone diagram is also called as Pareto diagram, Ishikawa diagram, Durant diagram. And the answer is Ishikawa diagram, because Ishikawa invented this fishbone diagram. It's a simple tool, but very powerful and very useful tool. Next slide. Following are the categories in the fishbone diagram: man, machine, material, method, money. Option 2, man, machine, material, method, measurement. The right answer is man, machine, material, method, and measurement. So the first option includes money, and money is not your category, right? So your categories are, especially this is for a manufacturing industry, categories are man, machine, material related causes, method related causes, and measurement related causes. This is how we are done with step number 2 in measure phase. So we started with listing out probable causes leading to problem in fishbone diagram, and we now categorizes different causes or sub causes for that matter. Not only causes, even sub causes as well, as we have seen in third example, right? So we have listed out probable causes and sub causes of the problem through fishbone diagram. So we started with defining how are we going to measure the problem through performance standard. Then we just listed out probable causes that may lead to the problem. Not those are not yet the significant causes, but these are the probable causes, out of which we'll find few significant causes. So this is about the causal finding, root cause finding through fishbone diagram. Now in next upcoming video, we'll just go through prioritizing those causes. So we'll select critical causes from the probable causes. So through fishbone diagram, we found probable causes, and here through next tool called CI matrix, we'll find critical causes. We'll segregate critical causes from the same probable causes which we found through fishbone diagram. I guess on that note, we're almost done with this video. As I kept on requesting you, if you're really liking our efforts, our drive, our initiative, please help us reach out to your friends, family, your relatives, and your network. Please let them know about the Breath of X program. This is for them. If you like our today's video, please click on a like button. Please share it, and please also subscribe our YouTube channel of Breath of X. So on that note, thank you so very much of your time. Please do take care of yourself, and we'll meet up in the next video. However, before we end, let's thank technology companies for their technological support. So we deeply appreciate following technological companies for their technological support. As I mentioned, these are not our sponsor companies, but without their help or without their technological support, we wouldn't be able to reach out to you. So we deeply thank these companies for their support. So on this note, thank you so very much for your time, and let's meet up in the next video to segregate critical causes or prioritize critical causes from probable causes, which we found through fishbone diagramming. Thank you so very much.